Hello everyone, this is Ross Eldridge, and today I'll be giving my presentation on the Project Part 4 Reliability Block Diagram. Before I get into the Reliability Block Diagram, I figured I'd show y'all what I'm actually working on this semester. This is the power distribution 1 line for the compressor station. You can see here you've got a utility feed. It comes down into a fuse disconnect and into a transformer that steps down from 25 kilovolts down to 480 volts for use at the site. If the utility power fails, you've got a generator right here, and that feeds into an automatic transfer switch that will switch between whichever supply is actually supplying power at the time. From there you'll come down into the low voltage switchboard. This is the main breaker right here, and from here you've got a busword that distributes the power to the motor control center, this power panel, 480 volt power panel, and there's actually another one that should be duplicated here. And then from there, this is the motor control center, or MCC 1 line. In this area here you see the compressor hot starts, which basically heat up the oil and the coolant in the compressor so that when it actually starts it'll be closer to operating temperature. It makes for easier starting, easier compression and use rather than starting cold. There's a couple ancillary loads here. You've got 3 tank heaters. You've got a crane inside the compressor building. You've got 2 instrument air compressors. You've got your 4 exhaust fans. And then you have a uninterruptible power supply, UPS. And then you've got a 120 volt lighting panel and a 120 volt heat trace panel, which basically just keeps the pipes warm up in the harsh cold conditions of North Dakota. Anyway, into the RBD, you can see coming in, the incoming power splits off into 2 parallel paths. This top path would be the utility feed. You can see that from here you get your utility power coming in on the power lines. It'll hit a pole mounted switch, and then it goes into the transformer, your high voltage bushings, your high voltage coil, transformer core, your transformer oil, the cooling fins for the transformer oil, and then the low voltage bushings, and then out to the transfer switch. If any of these units should fail, in theory it would just jump across to the backup, which is the generator. First you would have an under voltage relay. If your utility power is less than a certain threshold voltage, it'll send a signal to both the generator as well as the transfer switch to start using generator power. And then from here, this is looking at the different things you need to get the generator started. The battery needs to be charged so that the control panel can receive the signal to send the start command to the generator. As I was talking about before, a hot start so that you can be closer to operating conditions when you start. You obviously need a full tank of fuel. That's one of the human elements that can come into play with this generator. And then from there, you need to actually get the generator started, get it up to speed, and have it putting out rated power, and then not too much current to trip the breaker in order to get to this point here. And then from here you can see we've got the automatic transfer switch, and then from that it feeds into the switchboard main breaker. And then from here you can see we've got multiple parallel paths, which is a good thing for reliability. You can see the switchboard feeds the MCC, the 480 volt panel, and the other 480 volt panel. An intelligent engineer would distribute all of the loads on the site across many of the options that you have here. For example, the MCC has around 20 starters that you can use for the different loads, and you can distribute your loads across those buckets in order to keep a high reliability, try and keep the site running. Same concept for the two 480 volt panels. In this particular design, half of the hot starts are on this panel, and then the other half are on this panel, which also houses the PDC HVAC units, which one might not think are important, but with motor starters that are monitoring the current via temperature, you need to keep the PDC power distribution center at a relatively cool temperature. Think room temperature 60 to 80 degrees is what it's attempting to maintain, so that your motor starters will operate correctly. And then finally, you've got these last few items before you can say that your system will function. The most important on here, in my opinion, would be this guy, the PLC, Programmable Logic Controller. This is basically the brains of the whole site, and if this goes down, it's not possible to control anything on the site, and whether or not that shuts equipment down or it runs away and you have a catastrophic failure, it is arguably the most important part of the site. So some conclusions to take away. The system has redundancy in power supply. It's got both the utility feed and the generator feed. However, generators, as seen here, are notorious for being problematic and not starting up and distributing power when you need them. Next, you can see that there are a couple of serial paths after the power distribution. That would be the automatic transfer switch and the main breaker for the switchboard. However, these are typically engineered to be very robust, very reliable, and given a proper coordination study with your breakers, you shouldn't be having any problems with your main breaker or your automatic transfer switch. There are also parallel paths in the power distribution. As I said before, you can distribute your critical loads across the MCC or either of the two 480 volt panel boards, and this will give you a better reliability in your electrical system. And as I said before, the PLC is a very critical item. If this item fails, there will be zero control on the site. In a perfect world, everything would shut down. However, we know accidents do happen, so we need to keep that PLC running at all times if possible. Thanks for watching, you guys. Any questions, leave them in the discussion board on Blackboard, and I will get to them. Have a good day.